Hello, this video is the first in a series reviewing content for the physics and math sections of the MCAT. Specifically in this video, we'll be discussing units and dimensions. But first, before we start discussing units and dimensions, we should probably motivate why we want to study these things to begin with. Well, consider we wish to measure the distance between point A and point B on a table. And I tell you that the distance between point A and point B is given by 10. Well, this number on its own doesn't mean anything because it could be 10 inches, or the distance here could be 10 feet or 10 miles. It could be 10 kilometers, 10 meters. It could be any of these things. Or I could tell you that the distance from point A to point B is 10 pounds, or that it's 10 kilograms. But those two measurements don't make sense, because we know that pounds and kilograms measure weights and masses. They don't measure distances. So we already have some basic intuition about what units fit with what quantities. And with that motivation, we can begin to discuss some common units that you'll see on the MCAT. This is a list of the most common unit system with which you'll be working on the MCAT. This is called the SI unit system, or the International System of Units, which was formulated in the late 20th century. So, all of these units measure certain quantities. So, for example, if we wanted to measure a length, the unit associated to length is a meter, and meter is often written as m. If we wanted to measure the mass of something, we use kilogram, which is often written as kg. As a note, this is not a weight, so not a weight. As we'll see later, a weight is actually a force, it's not a mass. But continuing on, if we wanted to measure a time, we would use the unit of seconds, which is often written as a little s. If we wanted to measure the current, so the electrical current through, say, a wire, we would use the ampere, which is written as A. And the ampere is also written as a coulomb per second. And a coulomb here, this is a unit of charge. So it's a unit of charge. And if we wanted to measure, say, the charge of an electron or some other electric body, we would use coulomb in the SI unit system to measure it. If we wanted to measure, say, the amount of substance, as we do in chemistry, you would use the mole. And we often write mole as MOL, so you just drop the E for some reason. If we wanted to measure the temperature of something, we would use the Kelvin, which is written as K, or big K. As a note, Kelvin is one unit of temperature. You can also use degrees Celsius, or you may have even seen degrees Fahrenheit. But for the SI unit specifically, you use Kelvin. And on the MCAT, you may be required to convert between Kelvin and Celsius. And finally, if we wanted to measure, say, the luminous intensity of something, so given a light bulb, we want to say how bright is that light bulb. We can tell with our eye sometimes if one light bulb is brighter than another, but if we wanted to quantify it and give it an actual number, the unit we would associate with that number is called a candela. and that's often written as CD. So, as I said before, this is one unit system called the International System of Units, or the SI unit system. And it's used by most scientists. But there are other such unit systems. For example, the most generic type of unit system is called the metric system. So every unit system is a metric system, and this is just the type of units being used. So above we saw SI units, or the International System of Units. And examples of these are the MKS or CGS formulations. So MKS means that we're using meters for length, kilograms for mass, and seconds for time. So meters measure length here, kilograms measure a mass, and seconds measure time. But meters can be rather large if we're measuring something small. Say, for example, if we're measuring a paperclip, then meters will be far too big. And kilograms will be too big if we're measuring the mass of a paperclip. So there's another formulation of the SI units known as the CGS metric system, which is given by centimeters for length. So this centimeters is for length, grams is for mass, but we still have seconds for time. So these are two possible incarnations of the SI units that you will see on some problems on the MCAT. Another metric system used, especially in the US, is called the imperial or the British unit system. So an example of this is the FPS formulation. So for the length unit, we use feet or foot. So this is the unit of length. This is often the length of a ruler in the United States. For mass, we use the pound. So this is the mass of an object. So this is often written as LBS in the United States. And for seconds, we have time, as before. So we still use seconds to measure time. As a note, this is not required to memorize for the MCAT, but it is good to know that there are other types of unit systems besides the SI unit system. And you may even see these in everyday life. But all of the examples of units that I've given so far, such as meters, kilograms, seconds, these are all base units. So base units are the fundamental units of a metric system. So for example, kilograms, meters, seconds. In fact, all of the units on the table that I had shown earlier, so amperes, candela, these are all examples of base units. They're fundamental to the metric system. These are different than derived units. So derived units are a combination of the base units. So, for example, if we wanted to measure a force, as we often do in physics, you use the Newton, which is denoted by a capital N. And 1 Newton is equal to a kilogram times a meter per second squared. So what we do in order to construct a Newton is we take our fundamental units, the base units, and we multiply 2 of them and divide by the third. And we get a new unit which measures force here. Another example is work and energy. These actually have the same unit, and that unit is a joule. So a joule, often denoted by a capital J, is given by, so 1 joule is equal to 1 kilogram times meter squared per second squared. And if we look at the definition of a Newton given above, if we just multiply this by an m, we get m squared in the numerator, and that's exactly what we have for a joule. So we can say that 1 joule is equal to a Newton times a meter. So these are just some examples of derived units versus based units. And with that, we conclude this video on units and dimensions on the MCAT. Thank you.